Let's take this practical case to show you how the whole process works. We're using a 2mm thick cold roll sheet sized 1200 x 2400 毫米, with there as the cutting gas of a millimeter's margin reserved, and 100 pieces of each part to be cut. Now let's go through the whole process step by step. First, log into the software. If you have a hardware dongle, just plug it into your computer. Then you can use the local, seamless program without needing any internet access at all. If you are a subscription user, you are required to log in by scanning the QR code with WeChat under an internet-connected status. Scan the QR code here. Proceed to this welcome interface. Your historical nesting tasks show up here. If the drawing features a single material and uniform thickness, simply click New Nesting to proceed.
If the drawing involves multiple materials and varying thicknesses, you can utilize the multi-material function to process it.
You can specifically view the multi-material tutorial. If you need to import beveled parts, you can click this Bevel Import button. Since our sheet metal has a uniform thickness, we can directly create a new project. Click New Nesting. Set parameters based on our data. Configure nesting parameters at the top. Add sheet metal below. Click Add to include the standard version. It can also be deleted. Set margin to 4 mm. For adding compensation, lead lines, etc. to parts, use the automatic process function. Automatically adds processes to imported parts. Say we need to add compensation, just tick the Add Compensation box right here. Configure compensation value and corner processing mode. Click Confirm after the settings are completed. You can then enter the nesting interface. The nesting interface is composed of the following sections in total. The first section is the menu bar. The second section is the part list bar. The third section is the nesting layout bar. The fourth section is the nesting area. Next, we need to add the parts. Click Import Parts from Drawings. Next, we need to add the parts. Here, we will enter a pre-processing interface. The prompt here may indicate that there are tiny graphics in the drawing. All the parts we need have been identified. No need to handle it. Click Confirm. You can zoom in to see that compensation has been added to all the parts. You can see that there is such a series of numbers on the parts. If you need to mark this series of numbers, you can use the drawing mapping function. Set the text as marking, click Apply, and blue dashed lines will appear here, which represent the marking. If you need to set the text on the drawing as the part name, you can click Content Recognition, check Text in Parts, and set it as the part name. Once the processing is completed, we can proceed to nesting. If the drawing is indicated as faulty, you need to enter the drawing processing module to revise it. For a detailed processing tutorial, please refer to the drawing processing video. Enter the nesting interface. Here, the quantity of our parts is 100. Therefore, we need to make adjustments here respectively, and then the addition of our parts will be completed. The next step is nesting. Here we select Auto Nesting. Let us take a look. Click the Nesting button. When we do not check the parts, it will default to all parts in the part list participating in nesting. For sheet selection, you can choose the current layout here. That is, the current sheet. The priority of the sheet list is based on the sorting set here. The higher a sheet is placed in the list, the higher its priority in nesting. The intelligent sheet recommendation function ignores the priority settings and automatically matches the most suitable sheet for nesting. For the nesting direction, options include automatic horizontal, automatic vertical. For rotation angles, you can select 90度、180度, any angle, or no rotation. Select the following for options as needed. When the common edge option is unchecked, nesting will be performed according to the set spacing. When it is checked, the edges of adjacent parts will coincide, and the coincident edges will be cut only once, enabling higher efficiency and material savings. The next step is sorting. Click Auto Sorting. Set the cutting sequence between parts, as well as the cutting sequence of inner holes in the parts. The sorting method can be selected as required. We generally adopt intelligent sorting by default, which calculates the overall shortest idle path based on an intelligent algorithm. The effects of other sorting methods can be found in the video explanation below. Adjust the starting point and disable cutting direction change as needed. The same applies to sorting within parts. When we choose to execute sorting within parts, only then will the inner holes be sorted according to the parameters we set. Retaining the intra-part sorting will generate the sequence according to the original inner hole order of the part. There are 3 types of common edge toolpaths: single part C-type common edge, and common edge priority. The specific differences and cutting methods will be explained in detail in the subsequent courses. The specific differences and cutting methods will be elaborated in detail in the subsequent courses. For the leading lines of the outer contours of common edge parts, simply add and set the leading line type and length here. Since our parts are nested with common edges, we can set overcut to prevent the parts from warping and colliding with the cutting head. After all settings are completed, click Apply All and the settings will take effect for all layouts. All items are allowed to be modified. The scroll bar and buttons above can be used to check the sorting order. Let's drag it to have a look. It cuts sequentially along the direction of the long side. Leading lines for the outer contours have also been added. For the leading lines of inner holes, we can add them by clicking Leading Settings and then the Leading button. Set the type of leading line we need to add. Select the position of the leading line. Check the box for Apply to Inner Mole Graphics. Since these are inner holes of a common edge group, you also need to check Apply to Common Edge Group, then click Apply All. Zoom in to check that leading lines have been added to all inner holes. When all parts are arranged in the layout and the remaining sheet area is relatively large, you can generate leftover material lines and export leftover material drawings for reuse in future jobs. As you can see, there is a large blank area on this sheet. Let's add leftover material lines to it. Click Auto Leftover Material Lines. Select different types of leftover material lines according to your needs, and you can refer to the diagrams on the right for reference. It will then generate yellow dashed lines, which represent the leftover material lines. Click Export Leftover Sheet Material here to export the leftover material drawing. You can import the leftover material drawing right here. The skeleton line function is used to shred the leftover material after the entire sheet is cut, making it easier to remove the finished parts. Click Skeleton Shredding. You can set it either by spacing or by quantity. Setting the layers allows you to sort the skeleton lines and parts together. Details will be explained in subsequent courses. Let's add it and check the effect. This is the effect of the skeleton lines generated according to the parameters. Next is to export the report sheet. Our software can generate report sheets for quoting, processing, and other purposes. The software offers 4 types of report sheets: new version report sheet, Excel report sheet, single report sheet, and old version report sheet. We recommend using the new version report sheet. It has 4 built-in report types: processing sheet, quotation sheet, and single part quotation sheet, which can be used according to different scenarios. You can fill in the quotation parameters on the right side, simply based on the actual quotation information. Click Configure General Report Parameters to set the pricing method, which will be explained in detail in subsequent tutorials. You can choose to export it as a PDF or directly connect to a printer for printing. The final step is to export the machining task package. Click Export here, and you will see 3 options. You need to check the version of our cutting software and select the corresponding export format. Then open our cutting software. Click About under the File menu, and you will find the version information here. If your version is earlier than 730.1.5, export the second format. Otherwise, export the first one. Copy it to the cutting software via a USB drive. That's all for this session.